This video is for Math 1332 on Tuesday, July 18th. This is our second of 4 days in this first week of learning two sections. We're going to be learning section 1.3 and 2.1 today. So in MyMathLab, I clicked on assignments over here on the left. In the previous video, we did section 1.1 and 1.2, and over here on the side, you can't quite see it, but on the side, I have hundreds on both of those assignments. So I'm going to click this 1.3. This assignment has 12 questions. Okay, so this is problem solving is the name of this title of this section. If a student saves $72 per week, how long will it take to save enough money to buy a computer? So they're trying to come up with some realistic problem that somebody might be interested in doing in their real life involving math. And this is about saving money to pay for something. And then it says, what necessary piece of information is missing that prevents from solving the problem? So the computer's price, that would definitely need to be known because you want to keep saving money until you reach that amount. If you didn't know the computer price, you would never know when to stop saving money. Student's age, you don't need to know that. It doesn't matter how old you are. You can be young or old and save for a computer. That it has no effect on it at all. Today's date, maybe that seems a little important, but not really, because if you can only save $72 per week, it's going to be a set amount of time until you can buy the computer. It doesn't really matter what day today is. It's all about whatever day today is, how long is it going to take from here? So it doesn't matter if today's July or if today's December. If the problem said I need to save this to get somebody a Christmas present or a birthday present, then maybe the date might matter. But this is just they decide I want to get a computer at some point, and here's how much I can save each week. How long is it going to take me? Computer brand, that really doesn't matter. Again, if you may have already picked that out ahead of time. Maybe you went to the store and saw which one you wanted, and now you're just trying to, this whole problem's about planning for how long is it going to take till you have enough money. So the one piece of information we need to know is the price for sure, because that will be able to then decide how many weeks it's going to take to save up for that. So here's the same kind of problem, except now they want to know which piece of information is not necessary. So the other problem is there was one thing missing that we had to have. Now it's the other point of view. Sometimes word problems in math will give you extra information that you don't need to know. A salesperson receives a weekly salary of $500. In addition, they get $10 paid for every item sold in excess of 200 items. How much extra is received from the sale of 213 items? Okay, so which piece of information is not necessary to solve the problem? The 200 threshold, that would need to be known because apparently you just get $500 for your salary. And then they give you an incentive to make more money so that you'll work harder for the company. And they're the ones that set this 200. You have to sell 200 items. It must be like something easy to sell. So you're constantly selling items. And if you were just an average employee and didn't really care about the company, you would just maybe not work that hard. So this is to get you to work harder. And the 200 threshold is needed because that's how we need to know how many we have to sell first, where we don't make any extra money, and then we start making extra money after that. The weekly salary, that may not need to be known. If we're, how much extra is received? See, we're just talking about the extra money here is the question. So we already know we're getting the 500. We might not need to know that for how much extra is received. The number of items sold is definitely need to be known because we need that to go over 200 if we're going to make any extra money. And we need the $10 fee because if we sell 210 items, if we go over 200 by 10, then we would get 10 times 10, we would get an extra $100. So the weekly salary is important in general for the person who's making the money and working the job, but it's not needed for how much extra money you're going to make. So that's kind of like your base salary, and then how much extra money can you make? We already know that you're getting that $500, so that doesn't matter for this problem. Okay, so at the very end, it says the person sold 213 items. So they actually sold 13 items more than they had to start making extra money. So if you take the 213 that they sold and minus the 200 that you have to sell first before you can make any extra money, they sold 13 extra items than they needed to. And this is where workers might work harder because they want to make some extra money. So every item extra, they get $10 extra. And you just multiply that and get $130 extra. So that's why you need to know this 200, because that's what you base it off of. You need to know how many they actually sold. You need to know how much money you make per item extra. All that's information that is needed. The weekly salary was the one thing not needed. And then how much extra did they make? They made an extra $130. So that's good for them and good for the company. It's a win-win situation when that occurs. Okay, so here's just a different kind of problem. One more piece of information is given than is necessary. Okay, see, they do that a lot in word problems where they'll throw something extra in there to see if a student is bothered by having something they don't need. An architect is designing a house. The scale on the plan is 1 inch equals 5 feet. So 1 inch on the blueprint is 5 feet in the real house. If the house is to have a length of 65 feet and a width of 55 feet, how long will the line representing the house's length be on the blueprint? Okay, so again, there's information here that could be needed if you were actually building a house, and that may be why it's included in the problem. But if all you care about is you're at the point of your blueprint where how long will the line representing the house length be? All they're trying to do on the blueprint is draw the length of the house. So then you need to know the actual length that the house is going to be. And then you can get it down to this scale, what it will be on the blueprint. But even though the width of the house would need to be known to actually build the house, it doesn't need to be known for this blueprint part, at least not at this point. So the width of 55 feet, we don't need to know that right now. It might be needed later, or maybe they've already finished that part and they don't need it right now. But which piece of information of given information is not necessary? Because we also don't need to know the area of the house right now either. But it's not given. So they were trying to trick you here, even in the choices, that here's another thing that's not needed, but we weren't given that, so it's not answering this question of what given piece of information is not necessary. We do need the length, and we need the scale, because that's how we're going to go from the actual length down to the blueprint length. Okay, so now they want me to know how long will it be on the blueprint. So one way to do this is take that, what was it, 5 inches? No, 1 inch, sorry. 1 inch equals 5 feet. 1 inch equals 5 feet. When you have something like this, I like to make a fraction for this, which is called a ratio in math. And you can do this because since they're equal to each other, if you're doing anything divided by itself, it equals 1, and ones don't change anything. So this is the blueprint. The blueprint has this scale. And the feet is the house. The inch is the blueprint, and the feet is the house. So then I'm going to make a second fraction and keep the order the same. One of these two is also known, and the other one is what I'm trying to find. And this is called a proportion when you have two fractions equal to each other. They do this a lot in a geometry class in high school. And then in a proportion, you have 3 numbers that are known and 1 that's unknown. Here, the other one that's known is the 65 feet length of the house. Because remember, the 55 was extra information we didn't need. So we actually know the 65 feet. We don't know the inches on the blueprint, so that's the one I'm going to call X. Usually you just say X if you're looking for an unknown. So even in geometry in high school, in a proportion, you cross multiply. 5 times X is 5X. 1 times 65 is 65. And then solve for X by doing the opposite of multiplying by 5 and divide by 5. In fact, some people call this cross multiply and divide because you always have to divide at the end. And you can use calculators in this class, so just take out any calculator. 65 divided by 5 is 13. 13. So I would need the blueprint to have 13 inches, a little more than a foot, on the blueprint would represent the length of the house. Okay, one person earns $50,000 per year, another person earns $26.50 per month. This is common in word problems where one is in years and the other one's in months. They'll do things on different scales like that. How much more money does the first person earn in a year than the second person? So whenever they ask for how much more is something, that's a subtraction problem. If you make $50,000 and I make $40,000, how much more money did you make? You would do $50,000 minus $40,000. The only problem is you can't do that unless you have the same units. This is in a year and the other one's in months, so then you can't subtract. I need this one to be in years too. So I would just go off to the side somewhere on my scratch paper. $26.50 per month. If somebody makes $26.50 per month, there are 12 months in a year. So if you make that much every month and multiply by 12, that would be how much you make in a year. So $26.50 times 12. This person's only making $31,800 in a year. Now we have a fair comparison. Now both of these are in years. So how much more money does the first person make? That's when you subtract. If I subtract the bigger one minus the smaller one, that's how much more the bigger one is. 50,000, minus 31,800. So the first person makes $18,200 more than the second person. Okay, so I want to point out down here at the bottom too, if you get any kind of problems, even if you're watching these videos, sometimes students say, well, I watched your video and I saw how your problem worked, but mine just seems a little different and I can't understand it. There is some help here at the bottom on the homeworks. Help me solve this. We'll try to work you through this problem. View an example. We'll do a similar one. The reason they have both of those is if you're totally confused about a problem, you might want to have them help you solve it. Take you through the one you're actually working on. The only downside to that is even if you start doing that for a short period of time, as soon as now I know how to finish this, unfortunately, it's going to automatically restart you on a new problem with different numbers because they kind of gave away how to get to the answer at that point. So if you are just a little bit confused, then view an example might be better because they'll do a similar one and then maybe you can follow along, although that's what I'm doing in these videos. In essence, in these videos, I'm doing a similar example than the one you have. They have about 10 versions of every problem. So while you're watching these videos, you might say, oh, that problem number 5 is exactly the same one I have, but maybe once every 10 problems, you'll see the same exact one I have. And then what's nice is even when you get questions right, you can go back and hit this similar question at the bottom right. Similar question. So some students, they'll just rush through the homework. They want to get as good a grade as possible on the homework, and then they never want to deal with it again. And that's fine, but that may not be the best way to get good grades on tests. So that's why I suggest each day that a new video comes out, it's a very good idea to at least try to get through most or all of the homework on those Monday through Thursday days. And that way on Fridays and Saturdays, you're taking your tests either on a Friday or a Saturday. But most students are going to wait till later on Saturday to do it to give themselves as much time as possible. And that's fine, but you should go back and try similar questions right before you take the test at least once, maybe on Friday, and then do it again on Saturday morning. Go into all the homework problems, and you can just scroll through problem by problem and say, oh, I remember that one's easy, and I remember this one, and then when you get to one, oh yeah, that was that hard one, I don't know if I really understood that well enough, and I just got lucky to get the answer right, then you can try another. So that's a good way to practice for tests. Or even if you're doing the homework, if you just do one, you're like, and you kind of just punch something in your calculator and it came out right, and you're like, well, I just kind of guessed on that and got lucky. You might want to try another right away, right at that moment, and see that you really understand it or not. A television sells for $800. Instead of paying the total amount at the time of the purchase, the same television can be bought paying $100 down and $100 a month for 14 months. How much is saved by paying the total amount at the time of the purchase? So this happens whenever you buy anything. You can either pay for it right now, which a lot of people can't afford, or you can go on a payment plan. Now, anytime you go on a payment plan, you're always going to pay more that way. So how much more are you paying, and is it so bad that it's maybe not worth it? Or if it's not that much worse, then maybe that's the only way you can afford to get something that's expensive. Okay, so you're going to pay $100 down, and then it's a little off the screen here, but it's $100 a month for 14 months. So you're going to definitely, if you want to do the payment plan, you're definitely going to pay $100 right off the bat that day, and then you're going to pay another $100 for the next 14 months, which is, $1,400. And now you got to add that $100 because you paid that already. So you're actually paying $1,500 for that computer if you want to go on the payment plan. That's the larger amount. So always put the larger amount first. That's like, now we're trying to figure out how much more. So now it's similar to this problem. The computer only cost $800 if you had $800 in your back pocket, which most people don't. But if you had the $800 on you, or if you had done like that other problem about saving up so you can afford to pay it, that's a good plan for a lot of things, because see how much you're saving by paying for it up front? If you subtract this is how much you're saving. 15 minus 8 is 7, or you can do 1,500 minus 800 in a calculator. The payment plan, this is like interest money that the store is making off you. They're making money off you by giving you the item before you can pay for it. But you're paying almost as much in interest as what the thing costs. So you're paying double for the computer than somebody who can just afford to pay it up front. So if you would have just saved, so suppose you had this $100 and you didn't have $800, it would have only taken you 7 months to save $100 a month to get this, instead of paying them $100 a month for 14 months. If you pay yourself $100 for 7 months by saving the money, you could get the computer in 7 months. Now, maybe somebody needs it today, was what they're hoping. But that way you would save a lot of money in the long run. Whoops. So it's $700 could have been saved at the time of purchase if you would have paid it all up front by possibly saving up for it ahead of time. Calculators were purchased at $80 per dozen and sold at $25 for 3 calculators. What is a profit on 6 dozen calculators? So this may be some business. There's a small business that opened, and they sell electronics, and the manager or the owner of the store, they have to calculate these things in their business. So they need to buy product ahead of time and then figure out what it's costing them, and then they can set their prices from that, and that way they can plan on how much profit they might make. So calculators were purchased at 80 per dozen. Per means multiplication in math. So 80 per dozen. Dozen is 12. So this little phrase, 80 per dozen, is telling us 80 times 12. 80 times 12, it's going to cost them $960 to do this. The business would have to do this ahead of time. Then they would have these calculators in their store. And they sell them at $25 for 3. So these must be like real simple calculators, because if you buy a fancy calculator, each one costs like $100. But so these are like like a little calculator like this that can just add, subtract, multiply, and divide. 3 for $25. So every time they sell 3 of these calculators, they make $25. So that's just the business decided that's what they're going to charge people. 3 for $25. What is the profit on 6 dozen calculators? So 6 dozen, now I need to multiply this by 6 to see how much money it's going to cost the business to buy all these calculators. So multiply by 6, 5760 is, they'll actually spend $5,760 to get all these calculators. Now 6 dozen, there's 12 in a dozen, so 12 times 6, this is how many calculators they would have in their store when they first get them. So they bought 6 dozen calculators from some third party, and they have now 72 calculators in their store. And they spent almost $6,000 to do that. So and maybe this 25 isn't what they're selling them for. Maybe that's the profit. Let's say sold at. Okay. So anyway, they get $25 for every 3 calculators. So because of that, you have to take their total of 72 calculators. You have to divide by 3, because they're selling them 3 at a time for whatever reason. So that's what they were advertising as in their business is 3 calculators cost $25. So they would end up selling to 24 customers that way. If 24 different people said, okay, I'll buy 3 calculators for $25, they will sell that to 24 people. And they make $25 each time they do this. So the profit would be $600. So that's why it's a little confusing here, but because they're spending a whole lot more money than they're making, unless they mean that I think they mean that this 25 is their profit, although it sounds a little weird that it's sold at that much. 80 per dozen, 25 for 3 calculators. So let's see, 600, that doesn't seem right, but let's see. No, okay, I'm definitely doing something wrong. Notice the purchase price is given per dozen, yeah. Selling price is given per 3 calculators. You must express all prices per dozen, okay. Okay, so it says express the price per dozen. See, when you get one wrong, it'll tell you what to do. Sometimes that's helpful. So we want to do this 25 for 3 calculators. They want you to take that price and turn it into a dozen. So we'd need to multiply by 4. $100 per 12 calculators. And that's the dozen. So 80, 100 per dozen, and they're selling them for 100 per dozen, and they buy them at 80 per dozen. So that's the profit per dozen, $20. They make $20 every time they sell 12 of these calculators. what is the profit on 6 dozen calculators? So every dozen they make $20. So then you multiply this by 6, and that would be a profit of $120 at that rate. Since they make $20 every time they sell a dozen, then if they did 6 dozens, they would make $120. So that's one thing about these kind of problems, is you always want to get them in the same units. If one of them's per dozen and the other one's per 3 calculators, you need to get them in equal levels, is what's going on in that problem. Okay, each day a small business owner sells 200 pizza slices at $1.50 per slice, 85 sandwiches at $4 each. Business expenses come to $100 per day. What is the owner's profit for a 10-day period? So every day on average, they sell 200 pizza slices at $1.50 per slice. 200 pizza slices, and they sell each one for $1.50. So 200 times $1.50, that's $300. They sell 85 sandwiches, $4 each. $85 times 4, 85 times 4 is $340. So this is the money they take in every day. Every day they take in $640. Well, not every day, but on average, really. And their business expenses are $100 per day, so now you have to subtract that. The money you take in minus the money you spend, that's your profit. So this is the average profit per day. What is the owner's profit for a 10-day period? So now you multiply by 10. The owner needs to know these kind of things so they can plan for other expenses, or maybe major things like they got to remodel or pay for a new air conditioner. There's always things like that. $5,400. A local moving truck for a 3-bedroom apartment rents for $38.75 a day plus $117 per mile. Find the rental cost for a 2-day rental with 105 miles for a group of 3 roommates. Okay, a local moving truck for a 3-bedroom apartment. So the truck costs $38.75 a day. It's $38.75 per day. $38.75 per day, and we want to rent it for 2 days, so I got to multiply by 2 days. That's just the flat cost of the truck, and then they also drive you per mile, since wear and tear on the truck costs them money. $1.17 per mile, and we're going to drive the truck 105 miles. The rental cost for a 2-day rental, 105 miles. Yeah, the group of 3 roommates. See, there's extra information that's not needed because it's just 3 roommates moving into a 3-bedroom apartment, but they don't care how many people are in the truck. That doesn't cost extra to throw another person in the truck. It just slows you down and makes your mileage, your gas mileage, more. But the company doesn't care about that because they don't pay for the gas. You pay for the gas. $38.75 times 2. It's going to cost you $77.50 just for the 2-day rental of the truck. And then $1.17 for every mile you drive. If you drive 105 miles, that's another $122.85. So the total cost for the 3 roommates, and maybe they could divide this up by 3, the total cost. They can split the cost since they're living together. But that doesn't, again, matter to the rental company. $235. This is the total cost, whether one person's paying for it or all 3 of them share the cost. $200.35. Okay, Brianne decided to ride her bike from her home to visit her friend Dave. 3 miles away from home, her bike got a flat tire. She had to walk the remaining 4 miles to Dave's home. She could not repair the tire and had to walk all the way back home. How many more miles did Brianne walk than she rode? Okay, so she biked for 3 miles. And then she walked for 4 to get to this house. So there was a 3-mile bike and a 4-mile walk. The total distance from her house to his house must be 7 miles because you add those two amounts together. The biking distance and the walking distance, that's the total distance. And since she couldn't fix her bike, although you would think Dave would be nice enough to maybe give her a ride home, instead she had to walk all the way home that whole 7 miles. This was all walking. So she walked 11 miles total. That's a lot of walking. She walked 11, that's the bigger amount. She only biked for 3. How much more did she walk than bike? Remember how much more you subtract the bigger one from the smaller one. She walked 8 miles more than she biked. An automobile purchased for $33,000 is worth $2,500 after 5 years. Assuming that the car's value depreciated steadily from year to year, what was it worth at the end of the 3rd year? So when you get a car, it goes down in value the longer you have it, and other things can play a role, like how many miles you drive it, what kind of condition is it, has it had a lot of repairs or not. But generally, even if you buy it brand new and just leave it in your driveway and hardly ever use it, it's still going to go down in value. So it is only worth $2,500 after 5 years. So how much money have we used up on it? Subtract this. It was worth $33,000 and now it's only worth $2,500. So it's lost $30,500 worth of value in 5 years. So if I divide this by 5, since they said it depreciated steadily, that means if you divide by 5, you'll get how much it depreciated each year. Its value went down $6,100 per year. So if I multiply this by 3 for the 3 years, 6,100 times 3, it lost $18,300 in the first 3 years. So what was it worth at that time? Well, the same way you did this one. If I take the original price, it was only worth $2,500 after 5 years, so subtract that to get how much you lost. If it lost $18,300 in the first 3 years and subtract that, then you'll get what it was worth at that point. So 33,000 minus 18,300 is, it was worth 14,700 at that point. So basically what's happening, I can show to you a little slower here. The car was worth 33,000. Every year it loses $6,100. So another way to do this is you could just keep subtracting 6,100 over and over again. 33,000 minus 6,100. At the end of the first year, your car is worth 26,900. Subtract 6,100 again. Now it's 20,800. Do it a third time, and this is what the answer was, 14,700. If I do it 2 more times, I should get this 2,500. There's, after the 4th year, it's worth 8,000, and there it's worth 2,500. Now, the only problem is if you do it one more year, you would think your car's worth negative amounts of money, and a car can't be worth negative amounts, but so they don't really depreciate in a steady rate. It doesn't go down evenly. It slows down after a while, but that makes it too hard to figure out an answer to a problem like this. So it should be worth $14,700 after 3 years. I figure out how much does it lose each year, and I just do that 3 times, basically. Okay, before I forget, I want to mention that you get grades for homework. So at the end of each week, you're going to do 8 assignments per week, and preferably 2 per day, Monday through Thursday. And then that leaves you Fridays and Saturdays to study and review and take the test. Now, somebody could say, well, I'm way too busy in the week. I'm going to wait till Saturday after dinner, and then I'll use the last 3 or 4 hours to do all the homework and take the test all at once. If somebody can do that, that's fine, but you're probably not going to get a very good grade. So you're better off keeping up with the schedule of the calendar. Do 2 assignments per day, Monday through Thursday, and these videos will always be ready before you need them to follow along with. And then you save your Fridays and Saturdays for studying, reviewing, and taking tests. So you get a homework average each week. I'm going to take all 8 of your homework grades, add them up, and divide by 8. Now, if you get 100 on all 8 of them, then you get 100 average for that week. And then you get a grade for watching these videos. So in order to prove you're watching these videos, I'm going to give you a magic word of the day at some random point in the video. That way you can't just fast forward and try to find it. And if somebody might be able to, but they'd be spending more time trying to do that than just doing their assignment. So at different points of every video, sometimes I forget to do it too, and it might be at the end, but somewhere in the video that you probably wouldn't be able to find unless you were watching the whole thing, I'm going to give you a magic word of the day. So send me an email, or you can reply to I'm going to send an email out every day reminding you of what you should be doing that day and giving you the next video's link to get to. So you can reply to my email or just send me an individual one. In the email, all you have to do is do the date of the video. So in your email, you can just say, this is for the Tuesday, July 18th video, and tell me what the magic word of the day is. The magic word equals whatever. So today's word is Saturn, the planet Saturn. Just spell Saturn in your email. So Tuesday, July 18th, the magic word equals Saturn. That's all you have to put in your email. Send it to me. And that convinces me that you probably watched this whole video. Now, hopefully somebody doesn't watch the video until I give the magic word and then just stops watching the rest of it. But some people might do that. But they're just hurting themselves if they do. So send me your magic word of the day. There'll be 4 per week. And then you'll get 100 if you send me all 4. So you're doing your homework and watching the videos, that's kind of your daily work, and that's how you can get grades. And then the only other part of your grade is the test and the final. So the test and the final count a lot more than this does. So if somebody's trying to cheat their way through these, then they're just shooting themselves in the foot, really. So there's the one for today, and then each day there'll be a new word. Okay, and I wanted to do that before we finish this assignment so nobody could try to guess where it would be. So we're now on number 11. The members of the Student Activity Council on your campus are meeting to select 2 speakers for a month-long event celebrating artists and entertainers. The first names of the choices are Ben, Will, Stuart, Hillary, and Kate. How many different ways can the 2 speakers be selected? Okay. This actually, even though this is in the problem-solving section, there's going to be a whole chapter about this kind of a deal. So you're kind of getting a little prelude to doing this. So we're trying to select 2 speakers. And there's 1, 2, 3, 4, 5 people available. So what's happening here is you have to choose one of the 5 people first. And there's 5 ways to do that, literally. So the first one is easy because it's just however many total people there are. if you're going to a conference where there's going to be different people speaking, you usually don't get the same speaker more than once, at least not in the same day. So I'm going to assume that they're not going to let the same person do both speeches, and they would have two different people probably. It does say two speakers, but it doesn't say two different. So there could be a little bit of a debate. Are you including the possibility of letting one person go twice, or is it assuming that these are going to be two different people? So if whoever gets picked first, let's say Hillary gets picked, she's out of the equation now. So now there's 1, 2, 3, 4 people left. So after I choose one of 5, and I then have to choose one of 4 after that. And it turns out in a lot of these cases, whenever you're doing this and that, when you're doing things in succession, you multiply them together. It turns out ors are usually adding and ands are usually multiplying, although sometimes there's exceptions or other steps you have to do as well. But when in doubt, if you see an and, or if you have to do two things in a row and you want this and that, that's multiplying. So and then when another thing about word problems too is when you think you're done with a problem, always read the final question and make sure you answered what they asked for. How many different ways can two speakers be selected? So there should be 20 different ways that can happen. Order does not matter, okay. Maybe they are including the same person speaking twice. Okay, no, I know what it is that they're saying order doesn't matter. So I know what the answer is, but I'm trying to figure out a way that I can explain it to you before we actually learn that chapter, because you're going to learn this in a future chapter, so I can tell now that the answer is supposed to be 10. But how would you know to do that? Okay, so see, we're going to do something in a future chapter called a combination. And so I can tell this is 5 combination 2, which that's why I know the answer is 10, but we haven't learned that yet. So here's what I'm going to do. Let's see. Here's where you go to help me solve this. I want to see how they're explaining this. Order doesn't matter, okay. They're making a little chart here of 5 people. And they drew it in a circle, I guess, to emphasize order doesn't matter, okay. Oh, this looks complicated here. Okay, so now they're just pointing to different possibilities. Okay. So maybe, I guess what they want you to do is just point to every possible 2 people. So like W can go to H or W can go to K. Let's see if we can do 10 that way. Let me just simplify it to A, B, C, D to save a little time here. A, B, C, D, E. I got 5 people. So order doesn't matter. This is 1, 2, 3, 4. So now I'm done using A. I've got all 4 that use A. If I go from B, and I've already got B going back to A, so I don't go back to A. B can go to C, D, or E. There's 4 ways starting from A. Now there's 3 left for B. And then from C, you don't go back to A or B because you've already done them. So C can go to E or D. That's 2 ways. And then finally, D can only go to E other than ones it's already done. So 1 plus 2 plus 3 plus 4. That's how they're getting 10. And see, this is hard to do this. There's a much easier way that you don't know yet. So I can't give you this yet because you don't know it, but it turns out there is an easier way to do this in a future chapter. So this is all about problem solving, whatever it takes to solve the problem. They use drawing a diagram is often a good strategy in problem solving. And sometimes you have to get these problems wrong to see what they want exactly. And it doesn't hurt to, even I have to do it sometimes, look at help me solve this or view an example. And they may be doing it a different way than I would even think to do it. But sometimes also you have to assume things in a problem that may not have been stated exactly. Like I wasn't sure if they were allowing the same person to go twice, but apparently they're not. But even then, I still wasn't sure how they wanted that to be solved at this point. Okay, Sudoku is a popular game people play, and in that you try to get all the rows and columns to be the same. I guess this is a other version of it now, because normally you try to get the same. Here they want different sums. And this will help be in multiple choice actually on number 12. So I'm going to take the first part A choice, part A. You got this 3x3 box, and it's 745, 812, and 963. So normally you want every row, every column, and every diagonal to add up to the same thing. That's how the game's normally played. So they've created another version of it where every row, column, and diagonal has to have a different sum. And the way you can solve this in the problem solving section is, this is called a process of elimination. Just methodically going through until you find one that works, which couldn't be done if it wasn't multiple choice, but the multiple choice helps. So 7 plus 4 is 11, plus 5 is 16. 8 plus 1 plus 2 is 11. That's different so far. 9 plus 6 plus 3, that's 18. And use a calculator if you have to. So now I'm going to do the columns. 5 plus 2 plus 3 is 10. 1 plus 4 plus 6 is 11. So now we know this is not the answer. I didn't even have to finish it because I should have also done this column and then the two diagonals. If I could have got through all of that without any repeated answers along here, then that would have been the answer. So that's what you want to do. You want to do the 3 rows, the 3 columns, and the 2 diagonals. All 8 of those sums have to be different for it to be the answer. At any point you reach answers that repeat, as soon as there's a repeated answer, you can stop and you don't have to finish that one. So it's definitely not A. So it's not A. I'm going to go to B next. 725. 725. 618. 943. In the order you do this in doesn't matter. I can do the columns first if you want. 7 plus 6, 13, plus 9 is 22. 2 plus 1 plus 4 is 7. 5 plus 8 plus 3 is 16, so all different so far. 2 plus 7 plus 5 is 14. 6 plus 1 plus 8 is 15. 9 plus 4, 13 plus 3 is 16, but I got to repeat. So it's not B. Now maybe you'll get lucky and one of the first ones you try might be the one, but I haven't gotten it yet. So C, 785. 214. 963. So 15 plus 5, this row is 20. 2 plus 1 plus 4 is 7. 9 plus 6, 15 plus 3 is 18. So far all different. Here's 9 plus 3, that's 12. 9 plus 6 is 15. 9 plus 9, that's 18. There's a repeat. So by process elimination, it better be this one. Okay, so I just got unlucky by trying it in order. Sometimes when you have to try every answer, it's actually a strategy to start in the back and work forward, because they know that people do what I just did. That if you're just going to methodically go through each one and check them all, they'll try to hide the answer at the end sometimes. But apparently this sum here on top is 18. Here's 13 and 14. Those are all different. Here's 16, 9, and 20. Those are all different. And then there's an 11 here and a 15 there. So apparently all 8 of those are different. I didn't write them down, but That's what's happening here. All three rows, all three columns, and both of the diagonals, you can't even see the whole thing, but this one here, have a different sum apparently. And that's just process of elimination methodically going through. So I now have 100% on section 1.3, so I can save this and go to the assignments tab. Oops, that's weird. There it is. Okay. So again, section 1, 1, 1, 2, 1, 3. If you look over here, I got a score of 100, 100, 100. And it's not that you have to get 100 on all of them the first time you sit down. The one nice thing about homework is you can come back to it later. So ideally, you would do 1.1 and 1.2 on Monday and 1.3 and 2.1 on Tuesday. But if you get ahead or behind, it's not the worst thing in the world. But try not to get too far behind. Otherwise, people that do generally get very low test grades. If you can keep at or close to the calendar, that's your best bet for getting high test grades. Because there's people that literally wait till Saturday night, 9 or 10 o'clock at night, and then they haven't done anything the whole week. And they try to do all the homework and the test in an hour or two, and it's just not possible. And they get a terrible grade. Okay, we're switching to another chapter, chapter 2, section 1. This is called Basic Set Concepts. So there's 30 problems here, but these go much faster than those problems about problem solving. Okay, a set is basically just a collection of items. But you can be a well-defined set or not. A well-defined set means it should be very clear what's in there and what's not in there. Here it says the collection of current NHL players. See, this is something that's a fact, something that could be determined for sure. You could go to NHL.com and click their players tab, and it gives you literally the hundreds of players' names that are in the league. You can go to any single person in the world and say yes or no, this person's an NHL player or this person's not. So that's what's called a well-defined set. Because I can look at any particular item and say yes or no, this one's in there. Things that are not well-defined is when you start to throw opinions in there. The collection of the 5 worst NBA players. Well, that's somebody's opinion. Who you think is the worst player might be different than somebody else who thinks they're the worst player. So if opinions are involved, it's not a well-defined set. And then when we actually work with sets, we're never going to have any that would be like that. Okay, so just so you keep that in mind. See, here is a set. In a set, you put squigglies to let everybody know, okay, I'm making a list that's going to be a set. And then you can put words or numbers or equations or almost anything inside. And inside are things that are part of my collection, part of my set. And they have March and May here, which are months, obviously. So you could do all the months of the year and have all 12 months inside of a set. But since this is just March and May, it appears they want you to write a description of what this is about. This appears to be the set of months that begin with the letter M. Apparently there's only 2 months that start with M. So that's what a set can be. It's just anything you're interested in. Here's another set that has numbers, and it has 13, 14, 15, 16. You always just put commas between your items. And it can just be 13, 14, 15, 16 close squiggly. That can be a set. That's actually called a finite set if it stops. But it can have dot, dot, dot at the end, and that means it just continues in the same pattern that you've already established. I'm constantly going up 1, up 1, up 1, so that just tells me it'll constantly go up 1 forever. So it's not just the numbers 13, 14, 15, 16. That would be the answer if there was no dot, dot, dot. Numbers that come out exactly are called integers if you include negatives. If you just have positive answers, those are called natural numbers. Rational are all the fractions and decimals. So we don't have any fractions or decimals here, so it's not this one. So it's all the natural numbers that are greater than 12 because 13 is greater than 12. It's not all the natural numbers greater than 13 because that doesn't include 13. Now, they could have said all natural numbers greater than or equal to 13. That's another way it could have been worded. But in multiple choice, there's only going to be one right answer. So the description of some sets you might be able to describe them in more than one way, but whenever there's a multiple choice, there's only going to be one possible answer. And see, this one has 12, 13, 14, 15, ... but then they write another number. That makes it stop then. If it ends with ... it doesn't stop, but if you just is a long list, sometimes you put ... just because the list is too long. So this would be all the natural numbers from 12 to 26, and there could be different ways to say that. It's not all the natural numbers greater than 12, because that would go on forever. Natural numbers greater than or equal to 12 and less than or equal to 26. It could be that. That's one way to say it. It's not the natural numbers less than or equal to 26, because that would go below 12 even. The set of all numbers between 12 and 26, including 12 and 26. See, this could have been the answer, except it's not all numbers, because that would include decimals and fractions. This is natural numbers. And the set of natural numbers strictly between means not including the endpoints. So if they would have said strictly between 11 and 27, this could have been the answer, but instead it is B. But just so you see those other possibilities, they could have been the answer. Okay, another way to describe a set, this is called a set builder notation, is you put your squiggly, and then you put some kind of variable like X, just to say there's a bunch of possibilities that might happen. And then they draw a vertical line, and after the vertical line is a description of what it's about. So X is any month that begins with J. That's what they're trying to say here, is give me a set where the set is made up of random items that are months that begin with the letter J. So January and June, those are months. June and July are months, but we want all the months that begin with J, so January, June, and July. And it's not all 12 of the months, it's just the ones that start with J. Express the given set using the roster method. A roster method is what we had on those number problems where you just list every answer. The set of natural numbers less than 5. So natural numbers, again, are the exact numbers, only no decimals or fractions. And then less than 5 does not include 5. It could have said less than or equal to 5, but it just says less than 5. So that would be 4, 3, 2, 1. And the natural numbers start at 1, not 0. Whole numbers start at 0. Natural numbers start at 1, because the most natural thing that humans do when they're young is count things with their fingers. That's why they gave it the name natural numbers. So less than 5, you can list that because it stops at 1. If they would have said natural numbers greater than 5, it would be hard to list that, because it would be 6, 7, 8, 9, 10, 11, all the way forever. It would never stop, actually. Okay, now we want the set of odd natural numbers less than 4. There's only 3 natural numbers less than 4, 3, 2, and 1. And then we want the ones that are odd even. So that would just be 3 and 1, because 2 is not an odd number. Okay, here's another way to write this. Let me show you this. So they put the squiggly to say I'm going to start making a set. And then they usually put some kind of variable like X, just to say there could possibly be a whole bunch of possibilities and I don't know what they are yet. So X just means any random thing that could happen in my answer. And now I have to describe what's happening to X. You can do it in words or symbols. So writing this little expression right here means that X is a natural number. A positive exact number, in other words. So the capital N means natural number. And you're going to see this symbol actually coming up real soon in chapter 8. This is a symbol for is an element of. In other words, it's in my list. So X is an element of the natural numbers is how that's read. I want all X's, and this vertical line's read such that all possible answers such that x is a natural number and it has to be less than or equal to 4. So this one has the equal to. So this is 1, 2, 3, and 4. Less than or equal to 4 is 4, 3, 2, 1. Natural number stops at 1. If it said whole numbers, which they would put a W here, then you would include 0 too. And if it was integers, then you could include negative numbers, but we don't have that here. Here is same thing, x such that x is a natural number and it has to be greater than 4, but not including 4. So not including 4 eliminates these two. 5, 6, 7, and then the question is, does it go forever? Does it stop? This greater than 4 doesn't stop. Natural numbers go on forever. So unless they told me to stop at some point, then it's going to just go forever. And that's where you put the ... at the end to let the reader know it's not stopping at 7, it continues. Okay, in math, this double less than right here is a way of saying between. And in theory, you could do it 7 and 12. Okay, the one they have is 7 is less than or equal to x is less than or equal to 12. But it could have been with one of them having the equal to and the other one not, like these two, or they could both not have it. But in all 4 of these scenarios, this means between. And you always put the smaller number first, the bigger number second. It would never be the other way. And you would never put double greater thans or a 1 greater than or 1 less than. It's always double less thans. Double less than means between. And with these lines right here and right here, that means you include 7 and you include 12, but it could be where you're just like only including 12 and not including 7. And then they had the x such that x is a natural number. So that means just the positive exact numbers only. So the answer to this is squiggly 7, 8, 9, 10, 11, and 12. And it stops at 12. Say it was this one down here, the answer would have been 8, 9, 10, and 11. That one wouldn't have included 7 or 12. But mine includes both 7 and 12, so right there, 7, 8, 9, 10, 11, 12. See, now here we're not including them, so we want to be between 15 and 90 and not including 15, not including 90. But other than that, it's just going to be in between. So it's 16. It's going to start at 16. It's going to end at 89. Every integer, every whole number, every natural number between 16 and 89. And that list is too long to list them all, so then you just put ... after you've done a few of them. Okay, as I said, there's different ways to do this. You can do it in words, you can do it in symbols, you can just do a description too. So that's what they have here, is all x such that, and then they have an equation instead of a description. X plus 5 equals 9. So you could just solve this as a basic high school equation to solve. Subtract 5 from both sides. And equations like this only have one answer, so there's only one x that makes this true. I want all x such that this is true. Well, there's only one x that makes it true. So the whole answer is just 4. A set can just have one answer. And then you just don't put any commas. You just have that single thing inside the squigglies. And they want me to do the roster method where I list all the answers instead of multiple choice. So I just put my 4 in there. If there had been multiple answers, I would have put 4, comma, whatever it was next, and so on. Okay, so we need to talk about this next. If I told you to list me, and they're going to do this here in a minute actually, give me all x such that x is a month starting, remember that one where it said month starting with J? and we could list January, July, and June. X is a month starting with the letter Z. Well, January, February, March, April, May, June, July, August, September, October, November, December, none of those start with start with Z. Sometimes when you're trying to make a set, there's literally no answer that fits the description. When a set has no answer, it's called the empty set. And there's two common ways to write this symbolically. You either put a 0 with a line through it, or you put squigglies that are empty inside, literally empty, nothing inside. Don't do both. If you did squigglies, 0 with a line through it, squiggly, that means you have something in there. That's just some other symbol. It's the symbol we use for empty set, but somebody could have some other meaning for it. So never do this. It's got to be the 0 with a line through it, no squigglies, or empty squigglies if you think there's no answer. So on this one, they have the empty set symbol and just the regular number 0, and it's got squigglies around it. This is not the empty set no matter what, because the empty set, if there's squigglies, should have nothing inside the squigglies. So if you put anything in there, it's definitely not the empty set. This has 2 items in it, so if it has a size 2, it can't be the empty set. Empty set size 0. Okay. All X such that X is a woman who served as U.S. president before 1900. Well, they could actually put this, they could rewrite this and put before the year 2023 because we still have not had a woman president yet. So maybe someday we'll get a woman president, but so far not. And that means if I tried to write down the name of a woman who's been president either ever or since before 1900, clearly none before 1900, I literally can't write any names down. So this is the empty set. Unfortunately, there hasn't been a woman president, but hopefully we'll get one soon. But I can't answer this. There's no answer to this, so that's why it's the empty set. It can even happen mathematically. Are there any numbers that are less than 9 and greater than 15 at the same time? And means they both have to be true. Less than 9 are 8, 7, 6, 5, 4, and down. Greater than 15 is 16, 17, 18. I don't have any numbers that are in both of these at the same time. This is the empty set. Now, if they did it the other way around, if they said X is greater than 9 or X is less than 15, see, greater than 9 would be 10, 11, 12, all the way to infinity. And then less than 15 would be 14, 13, 12, all the way down to 1. If you're doing natural numbers anyway. And then you put the word and means what numbers are in both of these? Well, 10 through 14 are in both of these. 10 through 14. So if they switch these two symbols around backwards in this problem, then it wouldn't have been the empty set. It would have had 1, 2, 3, 4, 5 answers. And in these problems, you're not actually listing answers. If they occur, it's all about, is there any kind of answer or not? If this was greater than 9 and less than 15, then it would not be the empty set because I would have some numbers that are in both. But there are no numbers that are both less than 9 and greater than 15 at the same time. So that is the empty set. So we want all x's such that x has to be a natural number, and it has to be, remember this means between. Yeah, there are numbers between 5 and 15 that are natural numbers. There is 6, 7, 8, 9, 10, 11, 12, 13, and 14. So this is not the empty set. But if I did all x such that x is a natural number, and numbers between 5 and 6, not including 5 or 6, this would be the empty set. Because if you're doing natural numbers, they have to be exact numbers only. And 5 and 6, there is no exact number between 5 and 6. And neither one of these is being included, so then I wouldn't have any answers to write down. So that would be in a case where it is the empty set. This could have been the empty set, except there are exact numbers between 5 and 15. Okay, so here it comes. I told you this was going to happen. Now they're giving you some true-false questions. And this is a symbol you should know. They've got 17, and then they got this E-looking symbol, curly E. And then they got squiggly, 15, 17, 19, and 21. So this little squiggly E means is an element. In other words, it is in the set. It's in there. So true or false, is 17 an element of the set 15, 17, 19, 21? Yes, it is, because it's literally sitting in there. So that's why when you write squiggly and then put a empty set symbol squiggly, there's technically an empty set symbol in there. So that can't be the empty set because there's something in there. So that's just a misleading way to write that. Never do that. Students will do that on their tests, but then they lose points. So this is true. 17 is in this set. Is 21 an element of the set 8, 10, 12, ... 26? Well, by the pattern they've established, 8, 10, 12, these are even numbers. So 14, 16, 18, 20, 22, 24, 26 would be the whole set actually. But 21 is not an element in there because there are no odd numbers in this set. So this is false. 21 is not an element of that set. And it isn't whether you can physically see it. Sometimes you can see it or not, but you have to understand what's actually in that set before you really answer that. Now, these can get confusing when they do this. For my number 20, it says 14. 14, if you do the is an element and draw a line through it, that means is not an element of 1, 2, 3, ... 9. So when you get these ones with the not symbol, what you might want to do is do it normal first. So ask yourself this second one first. True or false, is 14 an element of the set 1, 2, 3 all the way to 9? No, it's not. This would be false. So then this one's true. That's how I like to do these. Because it can get confusing to say true or false, it's not in there. See, it's true that it's not in there, but that gets confusing when you have a negative in your statement. So, because you might say it's false that it's not in there, then it's a double negative. So I always think of it in the positive point of view first. Is 14, if it was is an element, would it be true or false? With is an element, this is a false statement, so therefore with the negation to it, then it becomes a true statement. The answer will be always opposite that way if you do it that way. So it is true that 14 is not in there. If you can do it directly, that's fine, but it does get a little confusing when you have the line through it. See, is it true or false that 12 is not in here? That's a little confusing. So I would think, is 12 an element of the set 1, 2, 3, ... to 35? See, this is every whole number, every natural number, every exact number from 1 through 35. Since they established a pattern, 1, 2, 3, ... 35, that means every natural number between 1 and 35. So if it said 12 is an element of that, that would be true. So therefore mine is false. I always think of it as the positive way first. And then the negative way is just the opposite answer. Okay, is 27 an element of the set where you have a random x answer such that x is a natural number, so no decimals or fractions, and you have to have x between 30 and 34, including 30 but not including 34. And this is a regular is an element, so I don't have to think about it backwards. Is this true or false? 27 is not between 30 and 34. Whether you include either 30 or 34 or both, it's still not in there. So this is false. 27 is not in there. Okay, this will trick a few people for two reasons. This is my number 23. They got 4 here. They've got the not an element. And then the other one's got 1, 2, 4. So even if you rethink about this in the positive way, if you asked, is 4 an element of 1, 2, and 4, you would normally say true to that. But by technicality, this is false. And then therefore, this is true because it's the opposite. And here's why it's false. For this to actually be true, it should have been written like this. This would have been true, and then this would have been false. Because that would be the opposite. But this, what I just did, is different than what they actually gave me. So this is why the squigglies are so important. When you put the squigglies, you're saying, I have a set. If you don't have squigglies, that's called an element. An element is an individual item that could go inside of a set. Without the squigglies, it's an element. And this symbol says is an element or is not an element. Well, this is a set right here. A set is not an element of a set. You have to be an element to be an element. You can't be a set to be, well, I shouldn't say that either, but by technicality, this is false automatically for the is an element. A set is not going to be an element of another set if they have just normal elements here. There actually is a way to make this true, and I don't remember if they have this as a problem, but if they were to put the set of 4 is an element of the set where you have sets inside of here. I've seen this before. This is another way to make it true. So these are, see, what the symbol is an element really means is whatever you see right here, whatever you have right here, it better be sitting inside the main squigglies, literally the same way it looks. And that's the problem, is this symbol here is not right there. That's why it's false. So my answer is true because this symbol is not that symbol. It's missing the squigglies. Whoops, did I say that backwards? True. Oh, I missed it now because of that. See, I wrote it right here and I clicked the wrong answer, but that's my fault. I got that wrong because I wasn't paying attention. But the original one that I thought of in the positive way was false. So then you switch it to the opposite. The correct answer is true. It's true that this squiggly is not in there. That's true, and I just clicked the wrong answer. So that's my fault. So I could do a similar one and try to get it right. See, it's the same kind of problem. So this is true. It's true that the squiggly 2 is not inside that set. Just the regular 2 is in there. Is -2 an element of the natural numbers? See, it could be because it's a single thing. It's not a set. But this is false because natural numbers are positive only. They're not negative. Okay, cardinal number is a fancy way of saying what's the size of your set. Cardinal number means size. And if you have roster method where they list every answer, then it's easy. You just count them. 1, 2, 3, 4. The cardinal number here is 4. If it's ... then it might take you a little longer to count. Just use your fingers. 2, it's going up by 4. So maybe I need to write them all out instead of counting on my fingers. They want me to do the cardinal number for 2, 6, 10, all the way to 42. So normally we just put dot, 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 because this is kind of a long list, but if I need the cardinal number, I'm going to have to add 4 over and over again. So add 4, add 4, add 4, until you get to 42. Add 4, add 4, add 4, add 4, add 4. There it is, 42. So the cardinal number is the size of this set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So with the dot, dot, dot ones, it can get hard because it can be a long list, actually. Okay, X is a month whose name begins with the letter X. No months begin with the letter X. Now, cardinal number is just how many. It's not the empty set. If they asked you to write the set for this, you would say it's the empty set. But cardinal number means what's the size of it. The size of the empty set is 0, and definitely don't put a line through it and don't put it inside of squigglies. So cardinal number is 0 through some positive number. Those are the only possible answers for cardinal number. And this is another way to write cardinal number. So let me make a list here because we're going to use this at the start of next class too. So what we have so far, let me just clear this page. So I'll see this next time. So far you have this symbol means is an element. And it better literally be sitting inside of another set to be yes. This symbol where you put a line through this means not an element. And I'm going to put this together. If you put n parenthesis and then some kind of capital letter can describe a set, this is number of elements. In set B, which equals cardinal number. It's a way to do it so you don't have to spell out in words cardinal number. So instead of saying what is the cardinal number like they asked for the last 2 or 3 problems, by just putting in symbols n parenthesis b, it's a shorthand way to tell the reader, give me the cardinal number. See, it even says find the cardinal number up here, but so you're supposed to know this notation means cardinal number. So I've got a set B, it's any random x such that x has to be a natural number, and it has to be a number between 4 and 5, including 5 but not including 4. So that cardinal number is 1 because 5 is the only one that's a natural number in that range, since we're not including 4. Okay, then there's another concept, and I'm going to add more. There's some more symbols you're going to learn in the next video tomorrow. But there's a difference in set theory about equal sets. Equal and equivalent are different, even though they're often synonyms in other areas of math. Equivalent. Equal just means they're the same size, same cardinal number. Equivalent means they're totally the same. Totally identical, totally the same. So not only the same size, but they have the same elements too. So you can have 1, 2, 3 as a set. This can be equal to 4, 5, 6 because they have the same size. But only 1, 2, 3 is equivalent to itself. Then it has to be 1, 2, 3. So then if it's the same size, that's not good enough. So see how these are not totally the same. There's 7, 8, 9, 10, 11. That's different, obviously, than 6, 7, 8, 9, 10. But they both have 5 numbers in them. So these two have the same size, but they're not totally identical. So equal. Okay, so I have this backwards, actually. I messed you up here. I thought they were going to give this one first, but I did it backwards. Equivalent is when they're the same size. Equivalent is the same size. And equal is when they're totally alike. I had it backwards. So 1, 2, 3 is equivalent to 4, 5, 6 in set theory because they're the same size. But only 1, 2, 3 is literally equal to 1, 2, 3. Maybe that's a good way to remember it. It literally is equal. Equivalent just means roughly equal, where equal means equal. So are they equivalent? Yes, they're equivalent in set theory because they're the same size. And this is saying the same thing. So another thing about sets is in a set, order and repeats. Order and repeats do not matter. So because they don't matter, then it's best for all of us humans anyway to list sets in order without repeats, because otherwise it gets confusing if they're equivalent or equal to other sets. So if your set is 1, 2, 3, 4, you could really write 4, 1, 3, 2. That's the same thing. It's not just equivalent. It's literally exactly totally the same thing. And you could write 1, 1, 1, 2, 2, 3, 4, 4. That's the same thing. So that's exactly equal to 1, 2, 3, 4. It's not just equivalent or the same size. It's totally alike, both of these. So if you don't want to get tricked by is something equal or equivalent, the best thing to do is don't write repeats and don't write them out of order. So if you're given 1, 1, 1, 2, 2, 3, 4, 4, that's really just 1, 2, 3, 4 if I get rid of the repeats. And if you're given 4, 3, 2, 1, that's really 1, 2, 3, 4 if I get rid of the out of order. So any set they give you, always put it in order without repeats before you try to answer anything. And then you really can't get tricked if you do that. So these two sets they don't look equivalent even. If they asked, are they equivalent? See, they usually ask that one first. That's why I got tricked by the order of this. But equivalent, they just need to be the same size. So 1, 2, 3, 4 is equivalent normally to 5, 6, 7, 8. Then the elements can be different to be equivalent. And you might think these are not equivalent because it looks like the set A is a lot bigger than set B. That seems to imply that they can't be equivalent. And that would normally be the case if there was no repeats, but there are repeats here. So don't try to do it with repeats. 1, 2, 3, 4 and 1, 2, 3, 4, these are equivalent and they are equal because they're exactly the same if you get rid of the repeats and put them in order. The sets are equivalent. And technically, all that you need for equivalent is that their sizes are equal. If the sizes are equal, that's equivalent. It's okay if they're also totally alike to be equivalent. And the sets are equal here because set A contains exactly the same elements as set B after you get rid of the repeats and after you put them in order. So any two sets that are equal are automatically equivalent no matter what. But any two sets that are equivalent may or may not be equal. Then they could have different elements actually. Okay, so I got a 98.333 here. And if you're happy with that, you can just stop and not work on this anymore. I can also go back to any one that I miss and just, if you're willing to work hard enough, you can try a similar one until you get it right. Because, see, they tricked me by putting this out of order. They usually ask for equivalent first. Because equivalent can be yes or no. And then if equivalent's no, then equal will definitely be no. But if equivalent's yes, equal could still be no. If you ask for equal first and you say yes, then automatically equivalent's yes. Now, these are not equal because they're not totally alike. 2 through 6 is not exactly the same thing as 1 through 5. So these are not equal. and therefore they could still be equivalent. In fact, they are, because they both have a size 5. So because they asked this out of order, then that's why I misremembered the difference between those two. But now I have 100 on this assignment. Save this. And then if I come back to MyMathLab, so I got a green check by all of them. So typically the videos will be somewhere between like an hour and an hour and a half. And our first video was a little more than an hour. And this one was right at an hour and a half. And I'll just show you here real quick. When it comes up, I have now done 1, 2, 3, 4 of the first 8 assignments that are all due Saturday night, July 22nd, 11:59 p.m. I have 100, 100, 100, 100 on the first 4. I have a 0 on the 5th one because I haven't done it yet. These extra reviews here at the beginning, they're going to be used during the final exam week to help review everything in the past. So they're not due till August 19th. But another thing you can do to study for your test, do all of these first 8 assignments that are all due July 22nd. Don't go to the 3.1 that's due July 29th yet. And you can always go back into any of the assignments from a given week and do them over and over and over again. You can try another and try another. Whether you get them right or wrong, you can keep trying another to practice more. Like I missed a couple of them, and then I just try another one until I get it right. And then you could use these reviews now if you want. I'm going to make a video for them during our 5th week. The last week of our class, I'll have my usual 4 videos of the week, and I'm going to work each of these reviews to help review for the final exam. But you can go in now and work on them now if you want. You don't have to, but you can work on this review week 1 while you're studying for the first test, because you can do the reviews a bunch of times until you get the grade as high as you want, and you can always try another even if you get them right now. So go ahead and use this now if you want, or save it till the last week of the class, or do it both. I would suggest doing it both, but you can concentrate on the homework for now. The homework you got to get done. You got to do these 8 by Saturday night. So I'll see you tomorrow for our 3rd of 4 videos this week.